Okay, hello everybody. What I want to do right now is just show you the calculations to do power, to find the power. I think it's important for you to see how you actually calculate it. That might give you a better understanding of what it is and how it gets, the power gets bigger or smaller. Now, this is one of those things in practice where it's kind of hard. I mean, some people think when we do these examples, why do we do it? Because if we actually know the actual average, the actual mean, why do we actually have to run the test? Well, in practice, you're not saying, okay, I know what the actual mean is. You're saying, you're trying to figure out how much can I afford to be off by. So you're saying, can I accept my answer if we're this far away from the actual mean? So could we say, if we are 5 away from what we think the mean is, are we still okay? So it's one of those things where you kind of double check and you just see if you're okay or not. Now, I put two PDFs on in the folder. One is the cola problem, can of soda. The other one is talking about water temperature. So let's look at those two problems. The first one I want to look at is the cola problem. Now, what I have here, this is what we're going to have to do the next couple days. Here's my whiteboard, okay? So we have our null and alternative, and I also calculated our standard deviation. So we have 3 divided by square root of 6. So the standard deviation we're going to use is 1.225. Okay, that's usually what I'm going to ask you to do first. Figure those out so we have those calculations done. Okay, now the steps we're going to have to go through here first, okay? Alpha is what we know. Okay, since we're assuming 300 is true, we control what alpha is. We can say our confidence level is 0.05, 0.01, and that's going to be our alpha. So if I were to draw a curve, since mu is less than 300, our alpha 0.05 is right there. That's what we can control because we are assuming that 300 is correct. And if that 300 is correct, what we need to figure out is what value would that line represent here that would make us reject the null. So if anything less than that 0.05, that's what we would consider a reject, okay, or rejecting the null, where we would say there is evidence for the alternative, which is less than 300. So we can get values less than 300 up to that point. If it's far enough away that it's that point, that's when we would say, okay, there's a significant difference, and we would reject the null. So we need to find that out. What is that value? So we have the 0.05. We know we're looking at less than. And what we're going to need to do is use the inverse norm. So I'm going to do inverse norm. I'm going to do it up over here. I'm going to move away from you for a second. Inverse norm. Remember, it is 0.05. Our average is 300. And we're using the 1.225. So the inverse norm function here is going to give us what that line represents. So that line, if you type it in, I have it as 297.985. I'm going to write it right above it. 297.985. Okay. So there's what that line is. Anything less, if we get an average less than 297.985, we would end up rejecting the null and say that our average amount in the can is going to be less than 300. Okay, so that's our first step. Now, the problem is that's not true. We know we're trying to see, okay, how far off can we be and be happy with our event. So if the actual average, in our problem, the first one says, illustrate your power of the test if the mu was actually 299. Now, what that does to our curve, it doesn't make it any taller or skinnier. Okay, the average is not affecting that. That's a standard deviation. Our standard deviation right here is going to be the same. What it does do is shifts. Okay, so that 299 is now going to be our center. So instead of 300 here, I'm going to draw another curve. Okay, pretend they're the same shape. But now instead of 300 being the center, everything's getting shifted over. Now our center is going to be the 299. Okay, now the 297.985, that's not going to be the same still. We're going down. That area is going to be different because everything's shifting over. The value is the same, but the area is different because of the shift here. Okay, and now what we need to do is find the beta which is this area over here. We need to find that beta, because the beta, remember, power is 1 minus beta. Okay, beta, it's going to be 1 minus beta, so we need to find that beta. And now that we know the 299, or now that we know that the 300 is not true, because we're assuming the actual is 299, that alpha is not worth it anymore. That alpha is not correct. Okay, so now that we're using a different average, we need to find the beta. And what we're going to do is use the value that we would use for the reject, the 297.985. Our average is 299. Standard deviation is staying the same at 1.225. And I'm going to just use my normal curve function, normal curve CDF. And I'm going to find what our beta is, which is from that pink line over. So if I'm doing normal CDF, okay, I know my lower limit is going to be the 297.985, some obnoxiously big number. My average is 299, and my standard deviation is 1.225. Okay, so I know I ran out of room here. Again, this is what we're going to have to deal with right now. I have 297.985 as my lower limit. So obnoxiously big number is my upper limit. We have 299 as the mean, and 1.225 as my standard deviation. Now, if I plug that in, okay, that's going to give me a beta of 0.7963. So that's the area over here. Okay, now what we need to find, though, since this is the area over here, which is what we can calculate because we know that average, we know that value right here is what we're looking for, is really just a normal curve problem. Power is going to be the probability of you rejecting the null when it is false. Rejecting the null is still this value here, this area over here, but we don't know what it is because we don't know what the average is. So we can do 1 minus beta to find that. It's just a complement here. So 1 minus 0.7963, and that ends up being 0.2037 as our power. So really what this is going to be saying, let's go up here, 0.2037. What this is saying is that if the actual average is 299 instead of the 300, which means the 300 is wrong. The 300 is incorrect. But for us to actually say we would reject the null in this case, there's only about a 20% chance of that happening, 20.4% chance of that happening. So really not the highest percent. The power is not that strong. Okay? So since the actual average and the average that we were testing, the 300, are close to each other, we have a smaller power in this case. Okay, the next video is I'll show you the bottom part of that where we think the actual is 295. Before you watch that video, I want you to think what is going to happen to the power. When we had 300 compared to 299, our power was 0.2037 or 20%. Now we're going to use 295. Do you think that power, again, it's the probability of us rejecting when the null is false, which is a correct answer. Okay, the power is the correct answer. Do you think that is going to get bigger or smaller before you watch that video? Okay.